Very nice. Thanks so much, Todd, for running all these videos. It's really nice to see known interviews you run, and there are many of them. I know we have an entire website full of them. I think we should link to that site with many more interviews from the website. And then also point people from time to time to the Macroscopes website itself. So if you go to the 24-hour events website, I think we have a link from the very first presentations, the 12 o'clock lunchtime event that Liesel and Todd and myself did today. And from there, you can go to the exhibit and ultimately also to see many different macroscopes that now exist. It is my true pleasure to introduce the next hour. And I think our next presenter arrived. So I will promote Nikita Rokotian to become a panelist. Thus, I think I can do that. Yes, I can. So the technology is much better set up now. Thank you all for making that possible. Nikita is part of the Macroscopes that were brought into the 16th iteration. And let me bring up my slides here so that everybody gets to see what I see in front of me here. Nikita, really, really nice to see you at this massive event, 24 hours live streaming. And I see you have your star. I have my gnome. Maybe I should make it glow, like warm, fuzzy feeling. And in that iteration, we have 4 macroscopes. And one of them is this very unique macroscope that truly helps to harness the power of data, and is going to be presented by Nikita from Interacta. And it's called an alternative data-driven country map. And it again is my true pleasure to welcome Nikita here. He is a data visualization engineer and designer with a background in physics and creative technologies. I wanted to follow up on those creative technologies. I think many people are very interested to be more creative, innovative, and any kind of technology that is helpful, I think, is welcome. He specializes in enriched data-driven experiences with strong dynamics and interactive components. And I had a chance to explore the Interacta website a little bit before coming into this event. And it's truly magnificent. And on the next slide, you also have the link to that site. Interacta is a data visualization studio where a team of developers, scientists, and designers are building truly beautiful tools for visual analytics. And I think in today's time and age, it really takes a team because you have to embrace and wrangle massive amounts of data. You have to explore and use and workflow different types of analysis algorithms. And you ultimately need the design skills to make it all work for a very specific user group. And so in 2019, one of the studio's projects called an alternative-driven country map won the World Data Visualization Prize, which is a very prestigious award organized by the World Government Summit, and Information is Beautiful. And so it's a true pleasure to have you here. And I will just give a peek preview of the Interacta website. So please find a way to check it out. And I will also post the link into the chat. And Nikita, it's really wonderful that we could join us at this time. And I will stop sharing here and give you the screen. And I hope you can share your slides. I think that has worked before. Try, please.
First of all, do you hear me well?
Yes, I can hear you well.
Okay, perfect. Yeah, let me share my screen and then we can start. Here we go.
I can see your screen.
Perfect. All right. Well, first of all, thanks a lot for the introduction and for showing our website and I'm really grateful for that, and I'm really glad to be here and present about one of our projects. And in fact, it was kind of a life-changing project for myself because, as you said, it was a pretty prestigious award. So it opened up a lot of possibilities for myself and for my studio as well. And so I have just realized that yesterday that it has been almost 5 years since we built the project. It was in early January 2019. So 5 years, yeah. And I remember it like it was yesterday. But a lot of things has changed since then. And we had a team just of 3 people. So we built that over the course of a couple of weeks. And first, okay, maybe 3 weeks, because yeah, a couple of weeks first, and then we thought, okay, we really want to polish up some details, and took an extra week, like almost full-time work. So it was unexpectedly big project for ourselves. And so yeah, we got this beautiful award, and later the project became a part of the Places and Spaces exhibit, which was also an honor for us. And yeah, we loved the project ourselves, loved working on it, we loved the technology behind it. So in today's presentation, I want to tell a bit about the project itself and about the underlying technologies we have used to build this map. First, well, you already did a detailed introduction, but I would like to say a few extra words about myself and my work. So I indeed have background in physics and in design. Somehow I think I got lucky to explore these 2 different worlds, and then later combine those, my interests and my skills, in something that I do every day right now, data visualization. And well, you already saw the interactive projects. I would like to mention that we have another big project that is an online tool. It's called Cosmograph. And I think it can be really useful for the audience of this talk, because Cosmograph allows you to visualize huge network graphs, like up to 1 million nodes, right in the browser. So you can just open the website, you can upload your CSV file with your network graph data and have this large graph visualization working on your laptop. So we have spent a lot of time working on this project, and I know that nowadays a lot of scientists actually use it. So I would like to take this opportunity to tell you about Cosmograph. And just recently we added some extra features, so you can also explore 2-dimensional machine learning embeddings. And in fact, the country map project, the data-driven map project, it is a 2-dimensional embedding, so I will tell about it. Yeah, so if you're interested in using those tools, feel free to go to the website and explore cosmograph.app. And another tool that I have been working on for almost 4 years, it's more for engineers. It is a library called Univiz, and it is a front-end library. It is open source that you can use to introduce charts, maps, or network graphs into your front-end project. If you're an engineer, you can just use this library, and it is platform independent. So you can use it with any front-end UI framework. Yeah. So, okay, let's talk about the project itself. So yeah, 2019. Information is beautiful. If you don't know what it is a project by David McCandless. He is a famous data journalist, and he has a book called Information is Beautiful. Then he created that platform that aims to explain, distill, and clarify complex information through visualizations based on facts and data. And they used to run this very prestigious award called Information is Beautiful Awards. And in 2019, I missed the deadline. And well, I was very busy back then working on some projects. And then in the end of the year, we saw an extra announcement that World Government Summit, together with Information is Beautiful, creating a new award. And we thought that it's actually the perfect time. It's Christmas time, New Year's time. We have some time off, so let's build a visualization specifically for this competition, for these words, and submit it. So that's how the project started. And the organizers, they approached the audience with 3 different data sets and 3 different topics. One was the future of government. Another one, the second one, was what makes a good government. And the third one was small countries are beautiful. And every topic had its own data set, its own big table with numbers. And those topics, they felt quite open-ended. Like those questions, they don't have an easy answer. And we decided to try to pick a data set that we find interesting and that we wanted to explore ourselves. And we really like this central question, central data set, central question, what makes a good government? So we wanted to try to explore it and think what we can build to present it. And it had around 180 countries and 32 variables. And those variables included different objective and subjective metrics. So like population or surface area, they're more or less objective, but indices like Happy Planet Index or Rule of Law, they rely a lot on survey data, so they're more subjective. And it is, in fact, very difficult to compare all of those different indices and even to understand what all of them mean. Nowadays, it is very easy. You can just take this table, give it to a large language model, and it will give you a summary of all of those different indices, different metrics. It can tell you how they were calculated, how they were measured. But back then, 5 years ago, it was a lot of work just trying to understand the underlying ways how this data was collected. And we were thinking what we can do with this data. And back then, I was lucky enough to work on a project that used an algorithm called XVI, which is a dimensionality reduction technique. And meaning that if you have a data set with a lot of numbers, so you have one data point that can be explained by a number of metrics, then this sorts of algorithms, they can reduce that number of dimensions onto a smaller number of dimensions, like 2 or 3, and then you can create a map. But it was kind of a new technique still back in 2018, 2019. So it was that algorithm, new algorithm called TSNE. I think it came out in 2016. And this algorithm, we used it on that project to create a map of sounds. So we have 1 second sounds, and we wanted to build an interface for the users to be able to tag those sounds. So every sound was represented as a point on this map, and we wanted similar points to cluster together so the users of the platform, they could maybe just select a bunch of points and give them a tag, and then use that to train on the backend to train a model, a machine learning model. So it was like a user interface problem, how you can make it easier for people to train a model, like to label the data set. So I really liked the experience working with this algorithm because it was looking very organic. Like it's interactive. It moves. The points move. They fly kind of float on the screen, and it's beautiful. So I enjoyed it a lot. And the fact that you can create a map out of any multidimensional data felt also very empowering. So, and then with this work, with this project, I thought that it's the perfect fit We can build a beautiful visualization, use the algorithm we like, and try to build a data-driven map of countries. And so I think it's the perfect time to actually do a quick demo to show the project, and then we will talk more about the underlying technologies of the project. So here, when you open the website, by the way, the link is right here. Oh, no, it's not right here. Sorry about that. So we will post it later into the chat so you can explore it on your own. But yeah, here it is. When you open the project, it is a website. You have a brief explanation of the algorithm, and then you have a background of the world map where every country has a point on top of it. And then a big button called Run Disney, run the algorithm. And when you press this button, you can see the points floating right on the screen. And this is the algorithm working in real time on your own computer, getting that data set and clustering the points together and building this unique data-driven map. And then we guide the viewers of this visualization through the key concepts. So we say that every point is a country, and every country is represented by various indicators and indices, such as population, GDP, Happy Planet Index, etc. And by default, the radius represents the population of the country. So you have two biggest points, China and India, as they're the countries that have the biggest population. And the color represents region. And you can change all of that later here in the dropdowns. But first, we allow the viewer to explore data set through this kind of narrative in the bottom. So we say that Disney cluster the points, but it doesn't tell you why it clusters the points in this particular way. So it's up to the viewer to explore the data and understand why certain points formed into clusters. And then we identify one distinct cluster, we zoom in, and we see the countries that are inside this cluster. And those are European countries, Japan, United States, Canada, Australia, and New Zealand. So those are the countries that we call developed countries. And they're represented by high values of indicators like political stability, control of corruption, judicial effectiveness, and others. Then we see we have another little distinct cluster, which is China and India. Well, probably they are together because they have the biggest population in the world. Then we have a Middle East cluster, which also has Singapore and Brunei. And well, we don't know why they are together, but I'm sure in the data there are some connections that making these countries form just one single cluster. And it's up to you, up to the viewer, to explore why it happened. And we do the same, we do this exploration for Russia and Brazil, which end up being very close to each other. But then you can actually change the variables that the algorithm takes into account. So we do it right here. So we click next and we disable population and surface area, and the algorithm remaps the data. And Brazil and Russia, they go different clusters, and now you have a different map. And what I love the most about this project is, in the end, we actually allow the viewer to play with the variables. So we say that, what if we pick the United States? And if we reduce health expenditure? And we do that, we reduce the health expenditure, and right in a second, the United States goes out of the developed countries cluster to somewhere else. So right now it ended up being in the bigger, like India, China, Indonesia cluster for some reason. And then we allow you to pick your own country and explore the map. And what I usually like to do here, I like picking different metrics right here on the top. and exploring, finding some interesting patterns, interesting outliers in the map. Let's say we want to check out Happy Planet Index, and I will do it both for both color and size because it makes it easier to actually read the graph. And then what really stands out is that in the developed countries cluster, there is one point, Luxembourg, which according to the index is very unhappy. I don't know why. So, and then you can keep browsing through the map, keep finding interesting connections, and by enabling and disabling certain variables, you can have hundreds of different maps. So, and even maybe if you have a certain task, based on your task, you can run the algorithm right here to produce unique map for your task, and it will help you to answer some of the questions. Right now, I would like to briefly talk about the algorithm behind it. So I already mentioned Disney. It came out in 2016. By the way, yeah, this is the URL. It came out in 2016. And I would say, you know, from 2010 to 2020, it was like the latest golden age of data visualization, specifically interactive data visualization. We have a lot of amazing, fascinating projects and even educational projects that use the power of data visualization to explain you how certain algorithms work in a visual, easy to understand manner. And that happened to Disney. So there was a wonderful project called distal.pub. It was a website like an online journal that created highly visual interactive articles about how difficult machine learning algorithms work. That made a lot easier for people to understand the concepts and how to use those algorithms. And the true power of those explorations was connected to their interactivity. And in order to use an algorithm, you don't need to understand the math behind it. You can just see how it works, you can interact with it, you can understand it by playing with it, and then you can use it in your work. So, and this interactive explorations allowed me and many others to use tools like Disney. So here you can write in the browser, select different data sets, and explore how the algorithm works. So I won't stop for a lot of time here, but if you're interested in these technologies, I highly recommend you to check out the website, check out the article. It is very interesting, and it gives you some actual advice on how to use the algorithm. For example, they say that the hyperparameters to use the algorithm, they actually matter. But some other things, they don't matter, like the cluster of the size on a Disney plot doesn't mean much, or the distance between different clusters also doesn't matter that much. Like things that you might think matter on a Disney map, they might not matter. And you need to keep that in mind while you're working with your data set. And what is the true power, real power of Disney, which makes it so addictive, is that you can actually visualize almost any multidimensional data set, but then it's very difficult to interpret the data set, to get some meaningful insights. So I think we really got lucky with this project because we got a lot of insight just from visualizing the data. Like we didn't have to spend a lot of time digging through to find interesting outcomes. And there's actually another algorithm. So after Disney, a few years later, another algorithm came out called UMAP, which effectively does the same thing. And its main differentiator from Disney is because it's way faster. And there is another beautiful interactive article about it as well, which kind of looks the same. So it allows you to run the algorithm, see how it works, play with it. And there is a comparison between Disney and UMAP showing that they do a similar kind of job. And what I really like about this article is this exploration in the middle of the article. So they have a three-dimensional chart of a mammoth skeleton, and then they have a two-dimensional UMAP projection of the data. And you can play with different parameters and see how three dimensions can be mapped onto two dimensions, and you can really see the same patterns, the same kind of visual features of the skeleton. And then they have a comparison between Disney and UMAP side by side. And I would say I like Disney more than UMAP. I mean, the result of the algorithm, it looks more detailed, more natural, more beautiful. But when you look at the algorithm execution time, it's 2 hours versus just 3 minutes. So UMAP kind of beats Disney on that side. So that's why the majority of people who use dimensionality reduction nowadays, they use Disney, they use UMAP, or there are even newer algorithms that are faster in certain use cases. And also, if you are truly interested in building visualizations like this, so we all built using well-established, even fundamental technologies of the web, like HTML, SVG graphics, CSS, style, everything. All of the websites are built using those technologies. So if you are interested in becoming a data visualization engineer, or you just would like to experiment with different kinds of data, different ways to visualize data, there is a wonderful library called XVI, which is nowadays an industry standard for data visualization. And this allows you to easily manipulate your data and map your data set onto visual objects, and like make a picture from your data. And what's truly wonderful about D3 is that it has a ton of examples. And the usual way how people learn D3 is not by reading a book, but by just exploring the examples and copying and pasting the code from examples into your own projects. So it is very easy. You have anything you can imagine. So it is a great library. And at the end of my talk, I would like to mention another project that won this year's World Data Visualization Prize. So it's actually the second prize. So the first one was in 2019, then COVID happened, and this year was the second edition of that award. And ironically, the project that won this year's prize uses the same data set. So we have some correlation here. If next year there is a competition, you might want to try the same data set again. And what's interesting about this project is, since it's the same data set, it shows you how you can look differently at it. And it is a completely different way to look at this data. Let me pull it up. I have it somewhere right here. So it is like a circular chart where you have all of those 32 metrics, and you have a distribution on the right. And then let's say you can pick high-income countries, and the other 2 dots on every metric mean middle and low income. And you can compare different income buckets with different countries across different metrics. And you can select here different regions and compare those regions with other regions, or you can select individual countries and compare one country to different regions. Like, there are many lenses to explore the data. So it is truly great to see that one data set can be visualized in such a different way. Okay, now it is the end of my talk. And if you have any questions, I'm happy to answer. And before we finish, I would like you, if you liked Disney and dimensionality reduction, I would like you to check out my latest project, which is called Market Map, which in fact is a similar kind of map, but it is three-dimensional, and it uses stock market data. So here, every circle is a company, not a country. And the project one, Information is Beautiful Words, is here. So I would love you to check it out. And if you have any questions, I'm happy to answer those. Thanks.
Nikita, this was very excellent. Really interesting to see some of your recent projects also. And congratulations also to winning yet another prestigious award. I was wondering, you already mentioned large language models and how they make certain things much, much easier. Are you actively using them in your projects? And if so, how do you do that?
Well, I use them in my work every day, and they really help a lot. I had one project where I tried to integrate the model, and it was actually Univis, the library. And that experiment was never published, but I tried to create an assistant, allowing the users to write code for themselves. Like, I was thinking, if we have this library and people use it to build data visualizations for their website, then they could open our website and just using human language, like plain text, ask how to build a bar chart with the line on top of it and some extra details. And the assistant would give you the actual code. And it worked maybe like 60, 70% of the times. It worked well, but the infrastructure to support that was pretty complex for an open source project. So we ended up not releasing it publicly. But I do think it's a very exciting time to experiment and actually see where large language models work and where they don't work. But they do a great job just to help you with everyday tasks. It's
Yeah,
like
I know
having your own assistant.
Yeah, and it's really wonderful that you, just like our team, you're trying to give people a fishing rod, not just a fish. So you give them tools to read their own data, to analyze their own data, to make their own data visualization, as opposed to not giving them tools, just giving them a new visualization. So I really, really enjoyed that you also presented work by others that empower many to really understand what the machine learning algorithms can and cannot do, how they work, how to interpret the results correctly, what matters and what doesn't matter, and then, of course, also interactively explore some of the parameter values. One of my PhD students, he will defend, hopefully successfully, his PhD thesis next week, Friday, so the coming week, Friday. And he tried to help everybody understand how data visualizations can be used to not just understand what input data exists and what issues might exist in the data, so that certain things just simply cannot be learned, but also to communicate to others how these machine learning algorithms learn. And of course, ultimately to communicate the results of the learning and the prediction ultimately as well. So I think there's a huge opportunity for data visualization to be valuable for optimizing and communicating how machine learning algorithms work. And again, I was very happy to see you present some of those first visualizations.
Yeah, well, thank you so much for inviting me.
And I put quite a few links to your work into the chat, which everybody can see. So feel free to add others. We are going to collect these different links, and we'll find a way to make them available with the recording. And so again, Nikita, thanks so much for coming in. I also will definitely come back to your new algorithm for laying out super large networks. I checked out the website, and it's highly relevant because many of our data sets are networks. We work on mapping the human body at single cell resolution, 37 trillion cells. And it's not just cells, it's also the genes and proteins and diseases and other elements connected to them. And then these knowledge graphs very quickly have 1 billion of nodes. And of course, you never want that on one screen because it's way too many nodes, more than you would ever have pixels. And so I think it's really interesting to then think through what it takes to have kind of nested graphs and drive through them. So I might reach out to you and just tell you a little bit more about our
I have noticed that a lot of biotech engineers and scientists use Cosmograph. And yeah, if you or any of the audience, you have any questions, we have an email, we have Discord, so please post your question there. We always answer all of the questions.
Very good. Thank you so very much. All right, in the interest of time, I think Todd has a number of videos that we would really like to have the audience see. And we will make your recording available later on, Nikita, so that everybody can see not just the man behind, or the team behind the Macroscope, but also some of the new works that you're doing and benefit from it. And it's really our hope that this event helps connect some of the good forces on this planet so that we can ultimately predict and pick desirable futures. So Todd, if you would like to share the next set of videos, that would be wonderful. Thank you, Nikita. True pleasure to see your work.
Thank you very much.
Change the World, a Gapminder video with Hans Rüssling.
It was the last 200 years that changed the world. I will show you in Gapminder world here the situation 1809. Each bubble is a country. The size show the population, and the color show the continent. The brown here is West Europe, and you can see from the map for the rest. This axis shows health, life expectancy at birth from 30 years to 80 years. And this axis shows income per person in dollar adjusted for inflation and for purchasing power. 200 years ago, all countries of the world had a life expectancy less than 40 years and had an income less than $3,000. Now I start the world, and you can see that the countries with good statistics, they are jumping up and down. There were famine years, there were better years, and West Europe and North America in industrialization started to grow the economy, but health didn't get much better. And slowly health was getting better. And when we came to a situation about 100 years ago, most of the countries of the world had not improved much. It was only this part of the world that was getting richer and eventually healthier and healthier. And between the First and the Second World War, you can see that the difference between the richest and the poorest in the world is just increasing. It was after the Second World War that most of the countries started to change. The green Arab countries here get richer and richer. China here is getting healthier and healthier. Now economic growth starts in China also. And the Arab countries, the green ones, they get healthier. And here we are today. We have a continuous world from high-income countries with long life expectancy to low-income countries with very low life expectancy. But all countries of the world today has more than, or are estimated to have more than 40 years of life expectancy. And all does not have more than $3,000 per capita. So it means that the world has become healthier and richer, but the difference still is enormous between the richest country and the poorest country. And there are also very big differences within countries, which we cannot show here. But to show how the change came about in a different way, I would like to compare two countries here. I will go back to 200 years ago here. 1809, and I would like to compare the United States with China. Look, 200 years ago, the economy was growing in the United States, whereas it was declining in China, that was dominated by foreign powers. Then health started to improve in the United States, but nothing happened in China. And in fact, it was not until modern China emerged here, 1950, that China really started to improve. That was, of course, the great leap forward. That was what Mao Zedong called it. In fact, it meant a leap downwards. But eventually China got a better health and then started with a fast economic growth and is catching up with the United States. And today the world looks like this. Some call it a flat world. It's not really flat. But what's meant with that expression is that the middle-income countries here, also called emerging economy, they have now a relatively good health, basic education for all, and some have very good education, are very capable, and they can compete with the high-income country in a completely new way, which we especially see now during the financial downturn. And in 2009, the income will fall in most of the high-income countries. It will be a very tough period for the low-income countries. Perhaps those will be worst hit by the financial downturn, whereas the middle-income countries continue to have economic growth, and the gap between the richest and those in the middle, that will probably shrink quite fast during the next 3 years. Now, you can look at the details of each country in Gapminder.